next presenter is Agnès Petit Markowski from Mobbot. So Agnès, if you're here.
Yes, can you allow me to maybe share my screen and video? Oh, yeah. Do you see my screen now?
Yes, it looks great.
Okay, right. Hi, everyone. Thank you, Daniel, for inviting me. It's really a big pleasure and honor to speak in this session. It's also a big recognition, I think, for a very young Swiss startup. So I'm the CEO and founder of Mobbot. It's, as I said, a Swiss-based startup. And we are exploring the 3D concrete printing in a slightly different way of the traditional way, I would say, which is we are exploring the sprayed concrete and how we can use sprayed concrete used usually in tunneling together with new automation technology and robotics. So how did we came to this stage is so it's only a less than 3-year-old company. We came to this technology because my personal professional career led me to work for about 7 years in a precast company as a product developer. And that's when I started being interested in how in digital fabrication and how to have more flexible, productive way to produce. However, the existing solution were not answering the needs, and I was facing one issue, which were infrastructure constructions. So we are focusing today on utility product very, very specifically. So it's definitely not the most sexy product for 3D printing and architecture, but it's a real problem on when you build a road or an infrastructure. And I want to share in this slide a couple of examples when I'm traveling, which I was facing when I was doing product development for infrastructure products. Very often on the construction side, the construction companies either use standard precast product for utility products, such as these ones, or they have to build cast-in-place elements for all kinds of water, telecommunication, and energy underground structures. And very often they face unknown underground or very bad planning. And this utility product is really the last interest of any construction company, because they are more interested in the asphalt, in the overall project planning, and the small concrete stuff is really the annoying part in the contract, so they don't care about this. But eventually this manhole can really mobilize a lot of resources on the job site. And that's where we started looking at how can we solve this issue of digital fabrication for this kind of applications. So urban areas are growing and have a high growing need for infrastructure solution. As I said, there's a lot of things underground, which is for water, utility products, for telecommunication and heating. And the best way to construct to build infrastructure remains concrete. You can replace a lot of concrete in and save a lot of concrete in buildings, as we just saw in the last presentation. But in an infrastructure, you really still need to construct and build in concrete to have sustainable infrastructures. However, the cast-in-place way to build these utility products takes quite a lot of time, especially in developed and urban area where you have quite a lot of obstacles underground. Just a simple 1 by 1 by 1 meter manhole like this can take 3, 4, even 5 days sometimes. And on the other side, construction companies use sometimes prefabricated, very cheap and startup elements. But then in this case, they have to modify. 8 times out of 10, they modify these standard products. So what we have developed at Mobbot is a solution that is basically a configurator that enabled the prefabricated prefabricating company or the construction company to choose online and very easily within a few clicks the shapes of this manhole with as many inserts as they want. If there's an obstacle, they can insert a kind of a door in this element. And from this configurator, we are exporting the data, loading this on our 3D, so on the robot, and spraying the element. We are spraying at a speed about 90 to 100 kilo per minute, which enables us to print an element like this of about 1,000 liter within 15 to 20 minutes. And this element can already be delivered the next day on the job site. So today, the company we are looking still for pilot projects, but we have also realized quite a lot of commercially already viable projects, especially in Switzerland. And the beauty of working in Switzerland is that you have the Swiss German and the Swiss French part. So you have kind of test market where you can test the different sensitivity to an innovation. And we have today more than 11 projects and 100 tons of concrete elements installed in everywhere in Switzerland. We have explored also the possibilities to integrate in BEAM projects, how to digitalize this element, just save some time simply in the design. And I will also briefly speak and show you an example what can we do else with this technology. So I think today we have reached quite a good acceptance of the product, the final product, so this manhole, 3D printed manhole. And we are now entering into a new phase where what we want is to offer the entire 3D printing solution using sprayed concrete. So we are providing this configurator and the robot, and we have now developed and deployed this solution at a prefabricated site or a commercial partner that offers and uses our technology for real projects. So now that we are still in this beta phase where we are still learning what, in which case it's economical and how often we can, what is the productivity with this methodology. But we have already seen that we are getting very close to the real economic value and also a productivity for our customers. So why would a customer or our partner are choosing this technology? Basically, it's for them when they get when they receive this robot, this spraying robot, it enables them to have quite a lot of flexibility. So instead of producing standardized manholes and selling them, what we are trying to build is a market where we can really mass customized, very simple product and deliver them just the next day. So the time saving for our customer, being it the prefab, but also the construction company on the job site, is extremely important. And even more importantly, when we are working in a very urbanized area, we do not want to open the trench and the road for a couple of days. We want to minimize the intervention as short as possible. And you see this in this video. I don't know if it's the speed of the video is good enough, but the way our technology is that we have a 6-axis robot which sprays concrete, and the spraying of concrete between the two shapers enable us to have a very good binding between the layers. So we are building a very monolithic structure like this. So this element here has been built in 64 minutes. It's quite fast. We can deliver it the next day. And very interestingly also for our customer, they can save quite a lot of concrete as well, because we can do bespoke product and we have very good performances. We have also a positive CO2 footprint for these elements. Now, beside manhole, which is our main interest today, because we are exploring this application, I wanted to share here an example of this application of our technology. What we work with Marc Mimham, so it's a architecture and engineering agency in France, for this retaining wall here for the bridge. And they have developed this solution with based on our technology. The idea of this was a competition. The idea of this prefabricated elements stacking on top of each other is that you have about 224 different elements sprayed. Each of them are sprayed, so it's a double spline here that we sprayed and stack on top of each other. So we have shown that yes, this is possible, and that could be another option or application we could follow. This was about 2 years ago. Today we have brought the technology a bit 1 or 2 steps further. So in terms of flexibility of shape and what we can achieve, or double spline angles that we can spray, we are much more also aware of this technology. And what I find very outstanding there, because I've done contour crafting, like really extruding concrete, when I'm as a user or our customers as the user, for them, what is very important is that the final product, the final prefabricated product, needs to be compatible with existing standards. And what we have shown is that thanks to our technology, sprayed concrete, we have really a pure monolithic structure, which is very similar or even better than some prefabricated elements. The other advantage, and where we are looking for also further save some material and CO2 footprint, is that using sprayed concrete, we can use local materials, so conventional concrete from our customer. And today we are also exploring the possibility to use recycled materials. So it's not basically what we have already a track record of different concrete recipe, and we can very easily integrate crushed aggregate, but also recycled concrete material as a raw material. And last but not least, we can also integrate some rebars. So these are not yet structural, but this is for the purpose of using manhole. It's not very decisive, but definitely we can spray around rebars, and it's also a big advantage of using sprayed concrete.
So and you asked for the 2-minute warning, so I just want to give you it. So
it's 2 minutes?
Warning.
Right, yes. So I'm coming to the end. So how do we tackle the SDG goals, so the sustainability goals? The reason to start Mobbot is to really decrease, to have a positive impact on how we build infrastructure, because we are wasting a lot of concrete in infrastructure. And a lot of people are interested in buildings, but where I see a lot of added value is how can we use this material in a better way for infrastructure. So what we want is really to focus on infrastructure there, reduce the consumption of material. And this is an example of we have calculated, so it's a real data. When we are building this manholes, instead of a 20 centimeter, which is today usually done on cast-in-place methodology, use 20 centimeter wall thickness with a standard concrete. Thanks to this technology, you can reduce up to a 12 centimeter thickness concrete element. And we have measured quite a lot of campaigns now with tensile strength, compressive strength, and the CO2 footprint per MPa here compared to the cast-in-place methodology shows us today, without using recycled material, that we are saving about 30% CO2 for each of these elements. So you could say, yeah, well, but it's a small element. Yes, but this is a more than $1 billion market, which makes it significant change. Finally, I just want to highlight the strength evaluation and performance with a Brazilian test that we did. So we are measuring since about 3 years the tensile and the compressive strength using our technology, and comparing sprayed and casted elements for the tensile strength. And you see here, these are the results over different campaigns compared to casted, two different types of casted materials. So we really see that when we using this technology, we have a monolithic structure, which is very similar to a prefabricated element. So today, our field of expertise is basically aerodynamic of sprayed concrete, where we have worked a lot and invested a lot of R&D to optimize spraying of concrete, new automation technology, the robot path planning, and the sustainable construction materials. So now the challenges and the outlook for the future will be now to deploy our commercial the technology, find and get feedback from early adopters. I think the big challenge for the construction is how to do this change management on the construction side. We have some economic consideration, but today we can say already we know in which case it's really economically viable. And as every startup, we have also technical robustness challenges, which we are heavily working on. And unfortunately, today, everyone speaks about sustainability, but this is not yet, at least in Switzerland and Europe, a tendering criteria for the construction, which I hope it will become soon. So I think with this, I'm finished with my presentation. So if you want to know more, just get in touch. You can follow us on social media, or you have here my email address. Thank you.
Thank you very much, Agnès. And of course, there are some questions for you in the chat, I see. So if you have some time, you can write back, and
Sure.
we will welcome you back at the panel at the end of the session.
Thank you.